In this video, we're going to go through how to simplify trig expressions using the identities that we learned. So go ahead and get your notes out where we have access to the reciprocal identities and the Pythagorean identities. So notice how we are multiplying in number one. So we're saying sine times cotangent times secant. When we're multiplying, when in doubt, go ahead and break everything down in terms of sine and cosine. And so sine is already in terms of sine and cosine, so I'm just going to leave it as sine. But times cotangent. So again, if I refer all the way back to cotangent, notice how cotangent is the same thing as sine over cosine. And so I'm going to rewrite cotangent as, I think I said that wrong, sorry. Cotangent is cosine over sine. I better make sure sorry, cosine over sine. From here, secant, we can rewrite secant as 1 over cosine. Now, I think the more you become familiar with these, the easier it'll be, but of course it'll take you a little bit longer at first to remember some of these. Now, why does this help us? Because anytime I have something, I can write it over 1, and what we see is that I have a sign in the numerator and in the denominator, meaning those simplify or reduce out, so we can cross those out. I also have a cosine in the numerator and in the denominator. The only thing left is a 1 over 1. That means all of this in number 1 reduces down to give us 1. It'd be like saying this complicated formula, and in the very end, you get down to 5 minus 4, and that reduces down to 1. That's exactly what happens here. Everything simplifies out, and so we're just left with 1. Now, number 2 is a little different because even though we're multiplying, technically this is a multiplication, and we see the parentheses, you may think, oh yeah, we're just going to distribute. That is possible. You can do it, and you'd get the right answer, but it might make it a little bit more challenging. One thing I want you to notice is anytime you see something like sine squared or cosine squared or secant squared or anything like that, I want you to think about these trig identities that we used before, the Pythagorean identities. Now, which one has a sine squared theta in it? This one right here. So because that has a sine squared theta, let's try to figure out how can we manipulate this first Pythagorean identity in order to make it look like this identity here, this 1 minus sine squared. Now, because this is a positive sine squared, if I subtract that over to the other side of my equal sign, then what would happen is cosine squared of theta would stay on the left-hand side, and this would equal 1 minus this sine squared theta that I just subtracted over. Now do you see how this 1 minus sine squared is the same thing as what we have down here inside the parentheses? So these are equal to each other. It's like we can substitute or replace this 1 minus sine squared with cosine squared because they are equal to each other. And so what I'm going to do is I'm going to rewrite this as secant theta times, instead of 1 minus sine squared, I'm replacing that with cosine squared because they are equal to each other. They're equivalent. They mean the same thing. Okay, now how does that help us? Well, now that we're multiplying even further, let's try to break down secant. So how can I rewrite secant? Secant is the same thing as 1 over cosine. And when I take 1 over cosine times cosine squared, isn't cosine squared just the same thing as saying cosine times cosine? And the reason I ask that, it's kind of like if I had x squared. Well, isn't that just the same thing as saying x times x? So we can go ahead and divide this out. Why does that help us? Because now I see, oh, I have 1 cosine in the numerator and 1 cosine in the denominator. So those divide out to equal 1, and the only thing I'm left over with is cosine theta. So all of this reduces down to cosine of theta. Now again, these videos are just introduction. I can help you more in class, and it'll get a little bit easier with practice. Now, number 3, taking a look at number 3, again, anytime I see tangent squared or secant squared, anything squared, I'm thinking about these trig identities. And so as I'm looking, I see, oh, here's tangent squared and here's secant squared. So I'm probably going to use this. So I want one of these to be tangent squared plus 1 or something like that. Well, notice I have a positive tangent squared and I have a positive 1. So let's rewrite them, just change the order. So I'm going to slide this up, and I'm just going to change the order a little bit, and I'm going to rewrite this as tangent squared theta plus that 1, and then keeping the same sign here, minus secant squared theta. So I didn't really change the problem. All I did was rewrite it in a certain order. Now, why did I do that? Because now notice how I have tangent squared plus 1. That's exactly what I have up here in my second identity. Now, what does tangent squared plus 1 equal? Well, it equals secant squared. So I can replace this tangent squared with secant squared because they are the same thing. They are equal to each other. So what is secant squared minus secant squared, or what is anything minus itself? Well, that would be 0. So this is why people don't like math, right? You have these complicated things and it gives you answers and reduces down to 1 or 0. But sometimes we also get answers like cosine. Now, it will get a little bit more challenging, but I kind of like this because it makes me feel like I'm doing a puzzle. And what we're trying to do is figure out how to solve it. So sometimes when we're multiplying, you want to pay attention here and break everything down when possible in the sine and cosine to see what cancels out. Sometimes you might have to look for identities first before breaking them down into terms of sine and cosine so that you see they cancel out. And so that's what we did here. Sometimes you don't need to turn them in sine and cosine because it'll just work itself out in the end. So it just takes practice knowing which strategy to use.